All right, these are the notes for learning targets 2, 3, and 4. Because they're all so related, we're able to go over them in the same lesson. What I've got here is an example of a sequence that you dealt with in the first homework, learning target 1, 25, 30, 35, 40. And I marked all the things that you learned from learning target 1 in blue. You know the n equals 1, the 2, the 3, the 4. You know the subscript and that symbol a sub 1, a sub 2, and so forth, right? The recursive pattern in this sequence is plus 5 every time. So the recursive formula would be a sub n equals a sub n minus 1 plus 5. And one more little part there, forgot to define a sub 1. A sub 1 is 25. It's just easy to do. And for that reason, I put it on the quiz. A sub 1 equals blank. So you have to fill in the blank. All right. And then the explicit rule, we would have probably taken a while to come up with it, but it's 5 times the n plus 20. All old stuff, right? All right, the new part, in red here, arithmetic sequence. An arithmetic sequence, and you can read with me, it's on your notes on the first page. We'll get there in just a second. It's the next slide. But on the notes in front of you, an arithmetic sequence, in fact, I can just go to the next page. An arithmetic sequence is a sequence where the difference between consecutive terms is constant. The thing that you're adding over and over again is the same number. And that thing that you're adding over and over again is called the common difference. So back to that slide. This plus 5 is now called D. D is 5. In an arithmetic sequence, we define that on the previous page. It's just any sequence where it's plus 5, plus 5, plus 5, plus 5. Or if you were adding a negative. If you're adding a negative 5 over and over again, it's subtraction. So subtraction is also arithmetic. The other thing that we're going to have that's new vocabulary is 30 and 35 are two arithmetic means between 25 and 40. All that arithmetic means is the new vocabulary. All that is when you're finding arithmetic means, you won't be given the two middle terms. You'll be asked to find what are the two numbers that go in the middle that makes this an arithmetic pattern, a constant addition pattern or constant subtraction. And then finally, the most important of all, for anything that's arithmetic, you have a formula that you can lean on and use for multiple things. And that formula is a sub n equals a sub 1 plus parentheses n minus 1 times d. While the arrangement of the letters and symbols may be new to you, none of those symbols should be new now because we just talked about what d is, right? You know what a sub n is. You know what a sub 1 is. You know what n is. And now we know what d is. All right, now we're speed it up a little bit. All right. Notes. The box at the top is a little disclaimer that I'm going to go through these kind of fast, starting now. And it's not going to be an exhaustive list of notes because it can't be. It's problem solving. You've got that tool, the formula, to do all kinds of things with it. And your homework's going to explore that. And I'm not going to be able to show you one just like every question in the homework. You're just going to have to play with it, see what you can come up with. It's kind of like the first time you used a hammer and a screwdriver and a Phillips and a saw. Yeah, you learned how to maybe use those things, but now go build a project. You're going to use them differently each time, but you got the tools still to use. All right, your tool is this formula. Part 1, determine if those four are arithmetic. If they are, tell me the D. Find the common difference, D. Pause the video while we try those. Okay. It doesn't take long to identify them, right? Because you're just looking to see if there's a constant addition. And there was in the first one. Yes, D was 4. Now, did you say yes or no on the second one? It's no, because even though it's plus 1, plus 2, plus 3, it's It's not the same number being added over and over again. So the answer, no, it's not arithmetic. The next one, 3, 6, 12, 24, pattern is times 2, times 2, times 2. That's not arithmetic. A little glimpse into learning target 5 after the quiz. That's called geometric. Geometric patterns are times 2, times 2, times 2, multiplication pattern. Okay? And then the last one. Yes, it is arithmetic. The D is minus 5, negative 5. It's adding a negative, which you would just probably associate with subtract. Nope. Good to go. And we're just getting familiar with them, okay? Now, I want you to pick one, either the first or the last. I'm going to do them both, and if you want to do them both, that's fine. But in part 2, I want you to use the formula that we just circled at the top to find the 20th term of either one of those two arithmetic sequences. I'll start if you need. You know the symbols over here in this formula. I kind of rewrote it for you right here. When you have a sub 20, you're in 20. So in the formula, in that parentheses, it's going to say 20 minus 1. A sub 20 means you're putting a 20 in the end spot. Your a sub 1, well, if we're doing this sequence, your a sub 1 would be 2. And then according to the formula, you multiply that 20 minus 1 parentheses times d, which would be times 4. So your 20th term would be 2, order of operations, plus 19 times 4. Pull up the fancy calculator. 2 plus 19 times 4. Whoops, 2 plus 19 times 4. 78. Pretty straightforward, right? Now, really what you did there, this formula creates an explicit rule for every arithmetic pattern. As soon as you put the A1 in, and as soon as you put the D in the formula, you've made it specific to the sequence of numbers you're dealing with. As soon as you put the A1 in and the D, it becomes the pattern you're looking at. So, for the sake of consistency, the next one would be if we did this fourth pattern, find the 20th term, it would be 10 plus parentheses 20 minus 1 times the D negative 5, which is 10 plus 19 times negative 5. 10 plus 19 times negative 5, negative 85. Straightforward, right? All right. Another use of the formula is to find the missing terms of an arithmetic sequence, the missing middle terms. Remember, that's called arithmetic means. So the first example and the second example, it's missing one term in the middle. C is missing 2 terms in the middle. There is a shortcut for this, and if you would like to either think about it and come up with it, or read about it on the pages that are at the top of your notes and find it there, I'm fine with that, but I'm not sharing the shortcut because I've learned in the past that you lean on that shortcut and you can't remember how to do it when the shortcut doesn't work. Because the shortcut will work in A and B, but it will not work in C, ever. So I'm going to teach it the way that works every time. All right? But there is a shortcut if you want to find it. All right, so the way that works every time is to use the formula we have been using. Let A1 be the 4, and let A3 be the 26. A1 in the formula, that 4 is going to have to go in the A1 spot. So I'm going to set up the formula. Something equals 4 plus parentheses minus 1, and then parentheses. Are we going to know what the D is? All right, so we're going to go ahead and put D here because we're not going to know D. That's what we're trying to find. Now the trick is remembering that you can use A3 and 26. It gives you 2 pieces of information. The third term is 26. So you can put a 26, A sub 3, on the left side when you put a 3 in for N. The third term is 26, so it gives you 2 pieces of information. All right, then finish it off. It's just an algebraic equation now solved. 26 equals 4 plus 2d. Subtract your 4. Divide by 2. 11 is d. And once you have the d, you can go back and fill in the missing term. Was that too fast on the algebra? That was algebra 1 is what that was. Subtract the... Is that okay? All right, so if d is 11, add your 11, and you get the missing arithmetic mean is 15. Go ahead for good, safe measures. Take the 15, add 11 one more time to it. Does it give you the 26? Yeah, so you know you got it right. All right, you do it for B. I'll pause it, and when I start recording again, we'll see all the work, and it will be finished. And there's the work, and the answer, the missing arithmetic mean, is negative 11. So I want you to start part C using what we just did. There will be a little change. See what you think you should do. Because you've got the tool, right? You've got the formula. And there's only one difference in what you did in part A and B. What's the only thing that's changed, or what's the thing that's different in part C? Right, exactly. That 61 is not the third term. It's the fourth term. So that's the only thing that's going to change. When you plug into the formula, A1, you'll be using A4. So the 61, see the negative 2 will still go there. But when you plug in the 61, it still goes on the left side representing the fourth term, but you put a 4 in for n. Okay? All right, then from there it's just algebra. 61 equals negative 2 plus 3d. Add your 2, 63 equals 3d, divide by 3, and you end up with 21 equals d. So we go back and add 21, get 19, add 21, and get 40. And just to be safe, we add 21 one more time, 61, you know you're right. There's no sense in even going up to the homework key and checking it. You know you got it right. Okay? All right, last two. Last target. In Learning Target 1, we wrote explicit and recursive formulas, right? But the pattern could have been anything. Today, the pattern is all arithmetic. It has to be arithmetic. And when we know it's arithmetic, it's a lot more scripted. It's a lot easier to write an explicit or recursive. In fact, some of you might even look back at your Learning Target 1 notes, or homework, sorry, and you'll find a few sequences that were plus 5, plus 5, plus 5, and you can do this on that old homework. You won't be searching in the dark for the formula. It'll just come out. All right? So let's first do explicit. For explicit, well, there it is again, the same formula we've been using all day. You're going to, like Learning Target 1, write a formula that has a sub n and something with n in it. And the only thing you need to do is identify a sub 1 and identify d and put them in. Identify your a sub 1, the starting term, and identify what you're adding each time and plug them in. So your pattern, over here to the right if you didn't see that. The a sub 1 is 5, and the d is 5, 2, negative 1. It's negative 3, right? You're subtracting 3. So the explicit formula will be a sub n equals 5 plus n minus 1 times negative 3. And if you wanted to, you could stop there, but that's not what it would look like yesterday. Yesterday, it would have been like 5n minus 1, or 2n plus 3, right? It would have been something like that. So, and I would prefer you go ahead, if you can ever reduce or simplify an algebraic expression, go ahead and do that. You can distribute the negative 3 to n minus 1 and combine like terms, so I would prefer you do that, okay? If you distribute the negative 3 to the n minus 1, this becomes 5 plus a negative 3n, or just minus 3n. And then a negative 3 times a negative 1 becomes plus 3. So your formula, the 5 and the 3 are like terms, and they become 8. So 8 minus 3n. Your explicit rule is a sub n equals 8 minus 3n. No more hunting in the dark if it's arithmetic to find an explicit formula. Recursive's even easier. If your pattern is subtract 3, subtract 3, subtract 3, you're going to take the previous term and subtract 3. So the recursive definition is always just put your d, your plus d, after the symbols that we've been working with. Any term is the previous term minus 3. And then define your a sub 1. What makes a specific arithmetic sequence specific? What term it starts with and what you're adding each time. That's the A1 and the D. That's all that's really important or specific to each pattern. I will, let's see, I'll just pause the video, let you do part B, which is just a little word problem, very small, still a level 1 type question, but when I turn the video back on, we'll reveal the answers and show all the work. But you give part B a try. All right, we're going to go through it kind of fast, but for the explicit, a sub n will equal 32 plus n minus 1 times 5. I prefer you distribute your d, distribute the 5, and combine like terms. So that will become 32 plus 5n minus 5, and then you combine the 32 and the negative 5, and it will say fit 5n plus 27. If you put 27 plus 5n, that's fine. They're the same. But your answer, a sub n equals 5n plus 27. That was a lot faster and a lot easier than thinking, all right, 1, 2, 3, 4, 5 above the numbers, and what do I do to the 1, what do I do to the 2 to make the term? That's what you're doing here. You're writing that rule the same, but it's just a lot easier because it's scripted. Recursive, a sub n equals previous term plus 5, and a sub 1 is 32. And finally, and I wanted to kind of do these live because I wanted to ask you which one you're using for part B. Which of those two formulas are you going to use to answer the question part B? Are you going to keep adding 5 fingers and toes? You can. But it's going to take you longer than it would if you use the explicit, right? Or you just plug the 15 in. You got a formula already right here that says if you want the 15th term, then multiply 5 times 15 and add 27. So 5 times, you probably already did it. What'd you get? Can't hear you. What? 102? Is that right? 102? So you're going to serve 102 people. All right, that's it.